Hello board aspirants, this is Shabnam. So I'm back with another topic, similarity of two triangles. So today we are going to understand the two conditions required for similarity of triangle and also going to understand the very important theorem, that is basic proportionality theorem, also known as Thales Theorem, or in short we can say BPT. Okay, so stay tuned till the end. The video is going to be very helpful. Okay, so let's start with the similarities of two triangles. Two triangles are similar if at very first their corresponding angles are equal. Okay, angles should be equal. For example, these are the two triangles, then this angle should be this equal to this, and this angle should be equal to this, and this equals to this. All the three angles should be equal and the side should be in proportion. For instance, these are the two triangles. Let us assume these are the two triangles. If you want that two triangles should be similar, two triangles similarities similar, it implies first condition required for this is all the angles should be equal. For 1 2 3 4 5 6, that is okay, all corresponding angles should be equal, that is angle 1 equals 4, angle 3 equals to angle 6, angle 2 equals to angle 5. Okay, first angle should be of first triangle and the other angle should be of other triangle. The second condition, okay, corresponding sides in same ratio or proportion. What is that ratio and proportion? Name them: A, B, C, D, E, F. Okay, that is one side of first triangle, that is AB, upon second side of this triangle, that is DE, should be equal to BC, this is C, BC upon EF, and it should be equal to AC or CA upon FD. I hope this is clear. Okay, so those two criteria is very important to remember, keep in mind. These should be fulfilled, only then the two triangles are said to be similar. Okay, so let's move to the BPT theorem, that is basic proportionality theorem. Let's read the statement and try to frame its diagram. If a line is drawn parallel to one side of a triangle to intersect the other two sides of distinct point, this is the triangle. Okay, if a line is drawn intersecting the other two sides, for example these are the two sides and this line is intersecting, and line is drawn parallel to the one side of a triangle. This is one side of triangle and other two sides क्या है? Intersecting point, distinct points पे intersect कर रहे हैं. The other two sides are divided in same ratio. अगर ये parallel है तो given हमें क्या है इस theorem में? So in the theorem we are given with that A, B, C, D, E, that DE is parallel to BC, क्योंकि हमने कहा एक लाइन कोई भी पैरेलल बनाएगी तो वो दो लाइनों को किस में बांटेगी? डिवाइडेड इन द सेम रेशियो. ओके, सो सेम रेशियो में बांटेगी. दैट इज टू प्रूव हमें क्या करना है, दैट AD अपॉन DB इज इक्वल टू AE अपॉन EC. ओके, सो दिस इज द थ्योरम we are talking about, BPT Thales theorem or basic proportionality theorem. Okay, so without delay let's try to prove this. Before solving the theorem we have to do two constructions. One, join DC, DC and BE. Okay, the dotted lines are showing that we have joined. The second is draw FG. Okay, draw DF perpendicular to AC and EG perpendicular to AC. Now proof is being done by finding the area of two triangles with basic formulas, that area of triangle ADE. Okay, how can we find? By base into height, half into base, that is AD, into height, that is GE. Okay, DBE, that is DBE. This is a triangle with obtuse angle, and a triangle with obtuse angle always have height at the back. For example, if you can see a triangle like this, it is an obtuse triangle and its height will fall automatically at the back. Okay, so the height will be GE, that is half into base, that is BD, into height, that is GE. Okay, similarly, if we find the area of triangle ADE again, why we are finding again? Because we have constructed two heights. Now we will be using DF. Okay, so again the two triangles we will be considering, and the other triangle is going to be this. Okay, that is area of triangle DEC. Fine. So the area will be half base, that is AE, and height, that is DF. Again the height of this triangle DEC. Okay, so it is again an obtuse angle triangle having angle more than 90. So height will be at the back, DF itself, half EC into DF again. Okay, by finding all these areas we can find something, that the ratio of two triangles, we want the ratio of AD and DB. So we will be having the ratios of these two triangles, that is triangle ADE and DBE, in ratios ADE and DBE. Okay, so the ratio of triangle area ADE divided by area BDE, what is going to be? If we divide these two areas, half cancel, GE will cancel GE. What we get? We will be getting AD upon BD. Similarly, we will be dividing these two bases, as we want these bases as ratio AE upon EC. So we will be dividing the area of these two triangles. Okay, so that is ADE and DEC. Okay, what we get if we divide these two? We will be getting half will cancel half, DF will cancel DF. Then we get area ADE upon area DEC equals to AE upon EC. Okay, now we are somehow very near to approach our what we have to prove, that AD upon DB is here, AE upon EC is here. Somehow if we prove that this portion is equal to this, the ratios will also be equal. So what is the difference between proving, what we have to bring here change in proving these two ratios equal? That we are having area ADE same, the below one is different, and below one, if we see in the figure, we can conclude something, that BDE and area DEC, area BDE and DEC are equal areas. Why? Because in previous class we have read that triangles between same parallel lines, okay, triangle BDE is between DE and BC, and again DEC is between DE and BC, between same parallel and on same base. The base is DE, and on same base, the base is DE, very necessary point. So the areas are same, it means the whole ratio will become same, and we can say that this is equal to this. So let's do it. What we have, that triangles BDE and triangle DEC lies on same base and between same parallel lines. It implies area triangle BDE is equal to area DEC. Okay, so from 1, 2 and 3. From 1, 2 and 3, what we can say, if these two areas are equal, ये भी equal हो गए, ऊपर का था तो पूरा रेशियो इक्वल हो जाएगा. It means from 1 and 2, 3 we can say that AD upon BD is equal to AE upon EC. By this our theorem completes. If you find this video helpful, if you find the explanation very easy, quite understanding, please do like, share, subscribe, and in the upcoming video we will be discussing questions based on BPT theorem. So stay tuned for that. Thank you very much.